We're in Pasadena at the California Institute of Technology. We're about to speak to Professor David Goodstein, who's the Vice Provost of Caltech. Welcome to the program.
Thank you.
When you wrote Out of Gas in 2004 and I interviewed you on the phone about it, gas had gone up to $2.30 a gallon. When I filled up today, it had gone down to $3.38. How does this reflect some of the themes in Out of Gas?
Well, it means that the gas prices are very unstable, and that seems to imply that we are close to the worldwide peak that's predicted in Out of Gas.
Talk about the worldwide peak and how Hubert's peak was predicted for the U.S. and how it came to pass and how it's been predicted for the world.
Okay. Oil as any natural resource.
Thank you. May I have the envelope?
Yeah. With oil, as with any natural resource, the supply starts at zero, it rises to a maximum, and then it declines forever. We will be in trouble not when we get the last drop of oil out of the ground, but when we reach the peak, because then the supply will start to fall behind demand. Hubbard predicted that the peak for the United States for the lower 48 would occur in 1970. He made this prediction around 1956. He was hooted out of the game at the time because everybody thought that was ridiculous, but it turned out to be right. Using similar data, a number of people have predicted peaks for worldwide oil consumption to occur in this decade. It may be that the price of oil indicates that we are very close to a peak, or it may be a false indication, and the peak might still be a decade or two off. A decade or two is not very long on the scale of human history. So we will be in a painful situation very soon.
How much oil was ever produced by the planet?
Apparently about 2 trillion barrels. The USGS, the United States Geological Survey, has made an extensive survey of oil supplies worldwide and estimates that there might have been 2.7 billion barrels, which would mean discovering the Middle East all over again. It seems unlikely, but if it's true, it would put off Hubbard's peak by about a decade.
How much is left?
About 1 trillion barrels.
Which means about half of it, give or take, has been used up already.
That's right, and that's when the peak is expected, when half of it is used up.
Can you explain why it's a problem that the peak is reached rather than the last drop is pumped?
Because when the peak is reached, the supply starts to diminish. The demand continues to increase, and so there starts to be a gap between supply and demand. That's a big problem.
And that's essentially just considering a straight line continuation of current trends without counting India and China coming into the picture.
Yes, that's correct. India and China are going to make matters much worse because they want to live like we live in an energy-rich environment.
So in this context, what possible effect would drilling in ANWR in the Alaskan National Wildlife Reserve have on the whole picture?
Very little effect because there's a very modest amount of oil in ANWR. We'd be better off saving it for use as petrochemicals rather than burning it up. 60
Minutes did an exciting segment 2 days ago saying that the oil sands of Alberta were virtually infinite. What effect will the oil sands of Alberta have, and what's the energy equation of the amount of energy it takes to get the oil out of the oil sands in Alberta versus how much extra energy is derived from that process?
The oil sands of Alberta used to be called the tar sands of Alberta. They changed the name to oil sands to attract investment. It takes 2 tons of ore, strip mined, to make 1 barrel of bitumen, a substance that cannot be distilled into gasoline because it's not rich enough. So hydrogen has to be added. So some of the world's largest plants for extracting hydrogen from natural gas have been built in Alberta. This indicates that it requires more energy to get energy from these sources. The oil sands of Alberta will never be a major contributor to worldwide oil supplies because you can't extract the oil fast enough. They are profitable now and will continue to be profitable, and that's fine. They'll make a modest contribution, but not a very large one.
On the question of how much energy you get out for how much energy you put in, what's the picture with ethanol? From corn, ethanol from straw grass, ethanol from any other material?
Yes. The picture with ethanol is probably that it's a net energy loser. It's not 100% sure, but many people think it is true. Ethanol from sugarcane is a net energy winner, and it's widely used in Brazil. But Brazil has a warm climate, and we don't have a warm climate, and so we can't extract ethanol from sugarcane. To extract ethanol from corn requires 2 steps. To extract ethanol from sugarcane requires 1 step, and that's the big difference.
I don't know how many people are still familiar with the saying, but there used to be a saying that the food in the Army, it's bad and there's not enough of it. I'm wondering whether that's comparable to the situation with oil, especially in terms of the greenhouse gases generated by its burning, and there not being enough of it.
Yes, there is not enough of it, and it's bad. And the greenhouse gases are a terrible problem, and one we must solve if we want to continue living on Earth.
Does burning ethanol generate carbon dioxide?
Yes, burning ethanol generates carbon dioxide as well.
So it would seem that a renewable, non-combusting form of energy would make the most sense. How about the sun?
The sun makes a great deal of sense. There's 20,000 times the amount of energy we are using now from fossil fuels raining down on the Earth from the sun. We have to learn how to use that energy. We have not begun to learn how to use it.
What are the existing technologies that convert sunlight into electricity, and what are the next few steps in the development of that technology?
Well, there are a number of technologies. One of them is hydroelectric power, because the enormous pressure of water at the bottom of a reservoir turns a turbine, which generates electricity. The water runs out, but it re-evaporates because of the sun and comes back into the watershed and replenishes the supply. So that seems like renewable energy, but you can't expand that because it's already saturated. We've built dams everywhere we can. Wind energy is another form of solar energy, and it's becoming increasingly popular, but it will only it's too intermittent and too undependable to be a primary source of energy, and so it will only be a supplementary source. The gold standard for solar energy is photovoltaics. It would take over 200,000 square kilometers of photovoltaics to supply the energy that we get from fossil fuels today. That's a tremendous amount. It's not a tremendous amount of land area. It's about half the size of the state of California. There's lots of unused land in the world. That's possible, but all of the photovoltaics made up to the present time would probably cover about 10 square kilometers. So 200,000 square kilometers is a very, very tall order.
Okay, now before we talk about the deployment of solar electricity, talk about the Stirling engine, how it works, and how it can be used to generate electricity from the sun.
Stirling engine is a heat engine. It works if you have 2 temperatures, one cool and one warm, and the internal mechanism pushes the air around and makes it go. It's been used in low temperature refrigerators, but it's never been made into an engine powerful enough to drive a car, for example. So although all thermodynamicists love the Stirling engine, I don't think that it's a very important resource for our future.
Well, a company called Stirling Energy Systems in Arizona has signed a multi-billion-dollar contract, 2 of them, one with Southern California Edison, one with San Diego Gas and Electric, to generate tens of megawatts of power out in the Mojave Desert using the Stirling engine. What's the does that affect your judgment on this?
No, tens of megawatts are negligible. We need tens of terawatts, which is 1,000 times more than a megawatt, to make a difference. So tens of megawatts is negligible, but it's contribution. It's something.
So what plan would you implement if you were the forces of the free market or of the government or both to solve the energy conundrum that you've just pictured here?
I think you have to pursue every possible lead. Every possibility has to be pursued, and tried out and worked on and implemented.
How optimistic are you that the public and the government decision makers and the private sector decision makers are fully informed about the gravity of the situation as you understand it?
I think they're not fully informed about the gravity of the situation as I understand it, and it's urgently important that they become informed. However, when I first started writing about this some 2 years ago, mine was a voice in the wilderness. Nobody was paying any attention, and now it's become part of the mainstream. It was part of the President's State of the Union address. And so I think a lot of progress has been made, and there's hope that people will catch on.
Now, specifically, Tom Friedman did a program on Discovery last week called Addicted to Oil. Former Vice President Gore has produced An Inconvenient Truth, and I just saw last week a film called Who Killed the Electric Car, all interviewing the same people, all making the same point as your book. And I'm wondering how what you said there fits into the context of these current discussions of these same issues.
Well, the fact is that the current discussions are occurring, and that's important and useful because people will become informed and maybe get off their duffs and do something about it. But so far, it has not happened.
What do you see as the role of scientists and technologists in furthering this discussion?
I think that scientists and technologists should tell everybody what the problem is and how, what possible solutions they have in mind.
During the Cold War, scientists, assuming they went along with the program, were lauded and lionized and made the centerpiece of various social affairs and so on. Is that the case now? And is the war on terror, which is paradoxically related to the energy crisis, a different situation for scientists? They're not lionized when they make statements that are inconvenient truths.
No, they're not lionized for making statements that are inconvenient truths, but they must make those statements. They will get credit eventually. But they must make those statements.
Talk a little bit about China and India, both as demand entrants into this market and as possible sources of technological innovation that could solve the problem for themselves as well as the already developed world in terms of the number of scientists and engineers that are being trained in those countries compared to what the U.S. is doing.
There are 1.3 billion people in China. Most of them believe that they will have a car in the next 5 years. That's an absolutely devastating fact. The Chinese make a great contribution to the solution of these problems because of the engineers and scientists they train. But so far, that has proved negligible.
Does it matter that in China and India, technocrats occupy a higher proportion of decision-making governmental positions than they do in the U.S.?
It might matter if they decide to take a different course than the U.S. took, but up to now they've followed the U.S. And taken the same course.
Okay, now a good deal of the oil that we're talking about here is burned in cars, and a lot of the Who Killed the Electric Car and other treatments of the subject try to deal with the impact of electric cars. And in fact, it came to me last night that essentially when we talk about mobile computers with electric systems, lithium-ion batteries, lots of microprocessors, cars are becoming big laptop computers. Is there a way in which the putting of more and more high tech into cars is likely to, and making them electric is going to solve any of these problems?
No, making cars electric is not going to solve the problem because the electric cars have to be charged. Charging them is a big problem because the batteries can't hold enough charge to propel them for very long distances. But in any case, they have to be charged. They're charged by energy that's produced by burning fossil fuels somewhere else, and so they're just surrogate fossil fuel burners. You have to revolutionize the entire system from the ground up to make a difference.
The makers of the film Who Killed the Electric Car, and to an extent Thomas Friedman in his Who Addicted to Oil, come up with the conclusion that locally generated electricity through photovoltaics or perhaps the Stirling engine can, at least in Southern California for a start, could generate enough locally created electricity to charge overnight lithium-ion batteries that would give people 30, 60 miles of range without using any fossil fuels, and allow most people to do most of their traveling on any day. You don't seem to think that that's a viable possibility.
No, it might be a viable possibility, but it has to be tried out. It has to be shown to work. You can't just talk about it. Talking about it is just vapor. You've got to prove these things.
Is there likely to be any solutions in more exotic technologies such as nanotechnology or even quantum mechanics to give some magic bullet that would solve this problem?
I don't see any magic bullet on the horizon. There might be one, but I can't see everything, but I don't see any magic bullets on the horizon.
What about hydrogen, which is touted by the administration, the federal President Bush and Governor Schwarzenegger as an answer to all these problems?
In the long term, when we have plenty of stationary power and we just need a fuel, hydrogen might be a useful solution. But today, it requires 3 to 6 gallons of gasoline to make enough hydrogen to replace 1 gallon of gasoline. That's not a very good deal.
And you can't make that up in volume, obviously. No. One solution that I've recommended and other people have recommended, and which doesn't seem to have caught on, is telecommuting as a way of avoiding all of the travel, letting people sit at their computers and aggregate in cyberspace and do their work. What's your view on that?
That could make a contribution, but it can't solve the problem, because people will be needed in actual places to do things. So telecommuting can be a partial solution, but it can never be the whole solution. If
the problem isn't sufficiently addressed and sufficiently soon, how bad could things get?
I think it could get very bad. It could be the end of our civilization.
And if things are addressed now aggressively, how good could they get?
Well, they could get pretty good. They could preserve the things that we think we need and give us a leg up on the future.
What's your best guess, or your expert opinion on what's likely to happen in these areas?
I think what's most likely to happen is failure.
And in order to avoid it, what steps do you think governments, business, and individuals should take?
The government should challenge the technological community to kick the fossil fuel habit now, when we still have fossil fuels, rather than later when we no longer have them. John F. Kennedy in 1960 challenged us to have a man on the moon within a decade, and we succeeded because the principles were well understood, and the problems were technological, and we're very good at solving technical problems. The energy problem is of the same sort. We're very good at solving technical problems. We understand the basic principles by which the energy problem could be solved using sunlight and nuclear energy, given the challenge, we could solve them, but it takes leadership, and we don't have any leadership.
Do you think that candidates for office, office holders who articulated a program along the lines that you're talking about would be able to get enough support, or would the sheer weight of television commercials telling people how happy they'll be if they drive big SUVs overwhelm that?
I think that in the short run, the SUVs might win, but in the long run, the sense of doing things right will prevail.
You're a historian of science as well as a scientist. As you look back from the beginnings of science to the present, are you optimistic that scientists working with the business sector and the government can solve this problem, or does it look like a big tragedy to you that the technology has been, in the end, something that's been a net destroyer of humanity rather than its salvation?
Well, the technology has made us dependent on oil, and oil is what's running out, so that's a minus. On the other hand, technologists are very clever people and can come up with solutions. So given the leadership, the political leadership, we can solve this problem, but I am pessimistic that we will solve it.
What 2 or 3 things would that leadership say to the people and do?
They would say, let us kick the fossil fuel habit now.
we've gone over all the alternatives the fossil fuel have it, and you haven't seemed to say that any of them by themselves,
there's no one magic bullet.
all of them together,
All of them together
would be sufficient, you're
might
saying.
be sufficient.
All right. Thanks very much.
Okay.